What is Kubernetes and why Kubernetes? In this video, we are going to see why Kubernetes is so much popular in the software industry. If you are in the application development space, you would have heard about Kubernetes. In most of the companies, they have Kubernetes as a major software as part of their software stack. So why this much importance for Kubernetes? That's what we are going to look into in this video. Before we look into Kubernetes, let us look into some of the architecture models that is existing. One of the architecture model is the monolithic service architecture. In this architecture, all the applications are bundled as a single deployable. For example, if you are having three services, which are loosely coupled services, maybe order management, order fulfillment, and invoicing services. In a monolithic service architecture, all these three services will be bundled into a one deployable, and that will be deployed into the server. One benefit of this one is for administrator, they have to manage only one service, or they need to monitor only one service, and it will be easy to manage then. This way, monolithic service architecture looks very much useful. Let us see how it works. Developer will develop the application and it will be built and it will be tested by all the teams together, because this is deployed as one bundle which is having invoicing service, OM service, and fulfillment service. So all the three teams need to work together, test it, and certify the whole deployable. Then we'll be deploying it. You can see that order management, order fulfillment, and invoicing together bundled and deployed there. Here, each of the service may need different sets of configurations, but as a bundle, it might need a resource that is a bigger chunk. Here, it's saying that, okay, the whole bundle needs 10 GB RAM, 170 GB disk, and the CPU capacity as needed. Maybe as independent services, OI might need only 5 GB of RAM and 150 GB of disk. Maybe order fulfillment needs 3 GB of RAM and 10 GB of disk. Invoicing may be needing 2 GB of RAM and 10 GB of disk. But still, when we deploy the application, we need a bundle of 10 GB RAM and 170 GB disk. That means if we need to scale this application, that means if you need to deploy multiple copies of this application, minimum resource capacity is what is shown here, like a 10 GB RAM and 170 GB of disk. Application level, we cannot do a resource management here, or service level, we cannot do a resource management here. So resource overutilization is one of the result of monolithic service. Another problem with the monolithic service is that, suppose the invoicing service is used heavily on the last month of the quarter, but order management service is used heavily in the first 2 months of the quarter. In this case, we cannot deploy more applications of OM or more applications of invoicing independently. We'll have to deploy more of the deployable, that is the bundle of the applications. Right. This way, resource utilization will be more, as we discussed before, and it is not independently scalable. Suppose there is a change for the invoicing service. Developer will do the change for the testing. Even though other teams are not affected by this change, they have to do the testing and certification, because they have to make sure that it is not, the change in the invoicing service is not making any regression for their service. So a heavy coordination is required. Because of this, most of the companies used to go for a periodic planned deployment. Some companies might go for a 6 months deployment cycle or 2 months deployment cycle, depending on their requirement. In this competitive world, each company's requirement is that they need to deploy their changes as soon as possible. So go to market time should be very, very small. That's what each company needs. With monolithic service, it's very, very difficult. So because of that, another architecture model came in, that is the microservice architecture. In this, what we are doing is we deploy each of the services, invoicing, order management, fulfillment, each of it as independent applications. So we don't bundle them together. That means developer will develop, testing will be done by only the OEM team for the OEM application, and it is deployed. And for the deployment, minimum resource requirement for OEM only need to be considered. That means here it says that 5 GB RAM and 150 GB of disk. If that machine is having that capacity, we can deploy OEM service there. Same way for other applications as well. So these applications are independent. In this case, whatever limitations we talked about for the monolithic service is eliminated here. So here we can do better resource management. Because each service is independent, we need to allocate only the resource required for that service. We can independently scale the application. That way, whatever we discussed of maybe first 2 months OM requirement is more, and last month of the quarter invoicing service is more. In that case, we'll deploy more OM instances for the first 2 months. Then last month, we'll reduce the OM and increase the invoicing deployments. And team coordination required here is very, very minimal, and go to market will be very fast because any change independently we can go and deploy there. So another development in the application deployment is the containers. In monolithic service or microservices, what we do is we bundle service as well as the dependent libraries together and deploy the applications. In the case of containers, not only the application and deployment libraries, we bundle the OS libraries as well as part of the container, and we'll deploy it together. Applications dependency on the backend host OS is reduced, or it is very minimal. Any application that is deployed in Red Hat Linux, but if the container is running on Ubuntu, in that case, that application behaves like it is running in Ubuntu OS. So it will not have any idea of what is the host OS. It need not know because all the libraries required for the application will be available within the container. The benefits of containers are they are self-contained deployables. They're highly portable. They are scalable because multiple containers easily we can spin up in a machine. And mostly platform agnostic, and resource distribution can be managed very well. These are the benefits of containers. From whatever we have seen from the monolithic service to microservice to containers, we have seen that our application maintenance or management process is very much improved. In this case, what is that Kubernetes going to provide us in extra? Actually, what is a Kubernetes? Kubernetes is a container orchestration system. We have seen containers. So Kubernetes will do the container orchestration. Let us think about, we are deploying containers independently. That means we are not using Kubernetes, and our application administrator is doing all the deployments. In a microservice architecture, there will be hundreds of microservices, and maybe each microservice may have multiple copies to support heavy incoming requests. So that way, our application administrator has to monitor all these services, and if so one of the service goes down, they have to bring that container up. And if one of the machine goes down, they have to deploy all these services into another machine. So many application administrators are required, and they have to constantly monitor these applications. So it's a tedious process, and it is a very hectic process. In the case of Kubernetes, Kubernetes will do the container orchestration. That means it will decide when, which machine, what container need to be deployed. We just have to provide some configuration file or manifest file. So application deployment management is done by Kubernetes. This is the example of a Kubernetes manifest file. This is for the deployment. Whatever we see here, this is the container image. We are saying that we need 3 replicas of the image, and this container's resource requirement is this. It's saying that it need minimum of 25 micro CPUs and 64 MB of RAM. So this way, we are telling Kubernetes that please deploy 3 copies of this container if that machine is having this much of resource capacity. So the rest of the things Kubernetes will take care of. That means making 3 copies of the application and making it available for the request, that will be taken care by Kubernetes. Automated rollouts and rollbacks. Suppose we have deployed our applications and there's a small change for one of the applications. One way to deploy it is shut down the application and deploy the new version and bring up the application. This way, customers see a downtime. To avoid that, Kubernetes provides a way to roll out the applications. Suppose 3 copies of the application is deployed. Suppose invoicing is having 3 containers deployed. In that case, we can tell Kubernetes to shut down one container, bring up the new application, new container, then shut down the next one. That way, gradual rollout can be done. Same way, if our new change is having some issues and we want to roll back, that also is possible to configuration in Kubernetes. Secrets and the configuration management. Secrets are nothing but the passwords of the database or the private key that we need to store for our application to utilize. This can be stored as secrets in Kubernetes. Another main benefits of Kubernetes is configuration management. Mostly, when we do a application development, we may have multiple environments. Development environment for developing our application, test environment for testing and certifying our application, and production environment for receiving customer requests. Each environment will change some of the configurations. Multiple ways we can handle it. Maybe through a property file which is part of the code, or a property file which is outside of the code, or we can store those configurations or config maps in Kubernetes. That way, each of the config maps in each of the environment will have different values that application can utilize. Application self-healing. This is one of the most important benefits of Kubernetes. That means if one of the container goes down, application administrator need not go and look into it and bring the container back. Instead of that, Kubernetes will take care of bringing the container back. In the deployment file, we mentioned that we need 3 copies of this application, right? So it is responsibility of Kubernetes to maintain that 3 copy. So if one of the container goes down, Kubernetes will bring it up in the same machine or in a different machine. Automated scaling of applications. This also we have discussed. If invoicing service load is high in the last month of the quarter, in that case, when the load goes up, the CPU utilization may go up, or the memory will go up, or number of requests, different metrics will be there to see how many requests are coming in. Depending on that, we can scale up our application. That configuration can be done in Kubernetes. Another benefit of Kubernetes is storage management. In Kubernetes, we can define different volumes. The volume could be of different sizes as needed by each of the applications, and we can attach these volumes to containers. That way, we can manage the storage requirement of each of the services. In Kubernetes, mostly instead of calling it as container, we call it as pods. Pod is a bundle of one or more containers in that. Why multiple containers are there in one of the pod is, if one container's output is a input for the other container. In that case, If these two containers are together, then the processing will be faster, network latency will be less. Such containers can be bundled together in single pod and deploy it. That way application will be faster. Whatever we discussed here are vast topics in Kubernetes. We'll be looking into those in other videos.